So we can say that this part of our presentation is going to be essentially the set of topic is the need for a copy constructor. Okay, and this is the outcome of the fact that we need to manage dynamically allocated memory so that each copy of int stack gets its own memory block, right? So it's obvious. So if we have one stack which manages this memory block right here, right? If we want to make a copy, we want to make a copy of it. It's an exact copy, except that it's going to be pointing to its own copy of integers and not share it with another version of the stack, right? So we have to manage the copy semantics and catch anytime there's an attempt to make a copy. We're going to catch that and say, hey, we're going to do something appropriate and make a deep copy. Let's take a look at what we can do. For this very reason, there is, if I open our in-stack header, open this in-stack header and go back. Remember I told you can have multiple constructors. So I will now add a copy constructor. So this we call the original version of the constructor a default constructor because it doesn't take any arguments. The second version of my constructor is going to be int stack, which is going to be an overloaded function, but this time its parameter will be integer stack, right? And it's going to be a reference to another stack. So I'll say another, right? I can name it another. So basically, somewhere out there is another in-stack object, and I would like to manage copying them, and I can do that by adding a copy constructor. This is called a copy constructor. Right? I would like to add a copy constructor to my class so that I can do something very appropriate at the time when it gets invoked. So I'm going to copy this, Control C, right? This is the signature of my constructor. Okay, and go to my implementation file, which is instack.cpp, or go to View, Solution Explorer, double-click the name of instack.cpp, because this is where I keep all of these functions. So somewhere this is my default constructor implementation, which was there originally. Now I'm adding this copy constructor, right? So obviously, as always, it needs a body, and of course, it also needs to say that, hey, this is, by the way, another constructor, but as all other member functions, it comes from the scope of in-stack, right? So make sure that if you made a copy of it, make sure to delete the semicolon, and also make sure that you specify that in-stack is in scope of the class, so the compiler is not confused by any of this. It knows exactly this is the copy constructor. So what copy constructor should do, it really needs to make sure that this type of behavior happens, right? So what we can do is this. First of all, we can say, what does the default version of the constructor do? So we can say, so first of all, it initializes the top of stack, right? And then it calls allocate memory. So this time, I can add constructor initializer list to the copy constructor and say the top of stack should probably be the same as another dot top of stack, right? So if I attempt to make a copy of this stack st2, st2 copy constructor will be invoked, and it will say another object has top of stack, and it's just an integer that specifies the position inside the dynamically allocated memory array. Okay, and then I can also say that capacity, which is another integer, should be another object capacity. Just simply take this capacity. Initializer list requires a comma separating the items on this list. And finally, with memory block, I'm going to say allocate memory, but simply take another object capacity as the size of memory that I need, right? So I'm just going to say I need this much memory, but that another object already has that capacity. I'm just going to create an identical stack, right? So now I have what I have done is that now I have created a copy of I mean, not the copy, I have allocated exact same space as the original object had, right? So this is right here in our demo. This is the original stack, and this is the copy named stack2, which happens inside this function named useStack. Okay, but now I also have to move all of the elements from here, right? This may have been already populated with some elements, so of course I need to move them and copy them over so that I actually populate my data inside of the copy with something that looks exactly as the original object. And that's the work of our copy constructor. So I won't invent anything fancy. I will say just, remember when we were reallocating memory, we already had a loop that did something like this, right? So I'm just going to do the same thing. After allocating some memory, I'm just going to copy and paste and say, so this is step number 1 was allocate exact space for dynamic array of integers, because we're using integers in our code, right? And number 2, copy existing data elements from another stack over, right? So we copy over to our own copy, and so I create this loop, and I say, look, this another object that exists out there, notice the use of reference, right? Notice the use of reference, so that we pass it by reference, and we say another object, a size, for as long as we're within the parameters of its size. Basically, our memory block will be populated by another stack memory block, and it's just basically becomes a version of the loop that says this equals another, right? So this completes the work. Basically, in this loop, I'm saying for each element in our own memory block, we will make it identical to the same corresponding element with an index within another stack size boundaries. We're going to just copy it over and make sure that we move every single integer over. And this is our copy constructor, right? So this time this should be safe, because I'm hoping that what happens here is that we decouple the resource management from one stack to another so that they manipulate separate dynamic blocks of memory, and now we are making this deep copy by using this constructor. I would like you to, so now instead of making a shallow copy, I can say we're trying to make a deep copy because we provided implementation of the copy constructor. Instead of relying on the default behavior that just like takes every bit and copies it over, we now do something more meaningful so that we essentially say, yes, we want pretty much the identical object, except it has its own memory that it will be managing dynamically, right? So if we do this time, when we call this function use stack, right? When we say use stack, and the copy is happening in scope of use stack, so this time when use stack returns, and this disappears, right, and this stack is destroyed, it will be destroying this memory, right? Upon return back to the original function who called useStack, the ST is intact and still fully operational. So this time, if I go and build this with the copy constructor, right, I can say build solution one more time, and again I'll just try running it. This time everything is fine, right? It no longer crashes, so no longer debug build kind of detects that something was wrong with memory. We're misappropriated this free store manager, memory manager facility. This time everything is fine. We're making all of this look kind of happy. So the program is back to normal.